All the software we use every single day, it's got this kind of hidden world of dependencies. And in that world, well, there are risks we tend to just ignore. So today, we're going to unpack a really powerful new way to think about those risks, and more importantly, how to get rid of them for good.
I mean, seriously, what if? Imagine for a second that before you installed anything, you got this complete, verifiable blueprint. A map showing every single piece, where it came from, and exactly how it was put together. No secrets, no just crossing your fingers and hoping for the best. That's really the core idea we're going to get into today.
Okay, so to really get why that blueprint idea is such a game changer, we first have to talk about the problem it's designed to solve. And that's something I call the black box problem.
So let me ask you this. Do you really know what's in the software you're installing? I mean, for real? When you type pip install or npm install, you're just grabbing these packages that someone, somewhere, built on a machine you've never seen using tools you can't check. We all do it. It's totally normal, but what are we actually putting our trust in?
And here it is, the heart of the problem. We're not installing the raw ingredients, the source code. We're installing pre-built packages, these compiled binaries. Now, don't get me wrong, they're super convenient, but you can't see inside them. They're totally opaque. They're a black box. We just trust that the binary we download is the same one that came from the public source code, but there's no way to prove it. The whole system is basically built on blind trust.
So right, how do we get from just trusting to actually proving? Well, it takes a pretty big shift in how we think about our software dependencies. We've got to stop looking at them as just a simple list of names and versions. We need to see them for what they truly are, a complete blueprint for our software.
And this right here, this is the key. Dependencies are not just artifacts you download. They're a graph. A dependency isn't some single file. It's the final product of this whole complicated build process, which has its own massive tree of dependencies. The real dependency, the thing that matters, is the complete map of how to build it from scratch. That's the graph.
Here's a good way to think about it. Imagine someone hands you a cake. You probably wouldn't just eat it without knowing what's in it, right? You'd want the full recipe, every ingredient, every measurement, every single step. A dependency graph is exactly that, but for your software. It maps out everything, not just the libraries you directly use, but the dependencies of those dependencies, and so on, all the way down to the very compilers and tools used to build the whole thing.
Okay, so this all sounds great in theory, right? Dependencies are a graph. But how do you actually use that idea in the real world? Well, that brings us to a tool called Fromager. It's built from the ground up on this exact philosophy. It's designed to give developers a way to rebuild their entire software stack right from the source, leaving absolutely nothing to chance.
Fromager's whole philosophy is pretty simple, but it's also kind of radical. It's this: no more pre-built binaries. Period. Everything, and I mean everything. The application itself, all its libraries, even the tools used to build those libraries, it's all compiled directly from source code. And it's done in an environment that you know and can reproduce every time. This is how you create a tool chain that's completely transparent and totally verifiable.
All right, so let's get into the nitty-gritty. How does Fromager actually build this graph? How does it figure out every single nut and bolt needed to put a piece of software together? It's a really cool step-by-step process.
It basically happens in 3 big stages. First up is pre-resolution. This is where it just figures out all your top-level needs. Then comes the bootstrap phase, and this is really the heart of it all. It starts walking down the dependency tree over and over, discovering not just your app's dependencies, but the dependencies of the build tools and the dependencies of those tools all the way down to rock bottom. Then finally, there's finalization. It takes everything it learned and writes out the complete dependency graph and the exact order everything needs to be built in.
And what you get at the end? That's the blueprint we were talking about at the start. The whole process creates this one incredibly powerful file, a graph.json. This is a complete map of your entire software supply chain. Now, technically, it's what's called a directed acyclic graph, or DAG. That just sounds fancy. All it means is that it's a map where everything flows in one direction, no weird loops. This file is now your single source of truth, the definitive, verifiable record of everything.
And if you were to actually peek inside that graph.json file, you'd see a node for every single package. And each node has all this key info, the version, where the source code came from, and this one, super important flag, pre-built false. That little flag, that's your proof. That's the guarantee that this piece wasn't just downloaded as some mysterious black box. Nope, it was built from source, by you, in your environment.
Okay, so we've talked about what this is and how it works. But now for the big question. Why go through all this trouble? What's the actual payoff? Well, it all boils down to two huge things: trust and control.
I mean, just look at the difference. The old way, with pre-built binaries, is totally opaque. You just have to trust it. But with the Fromager way, building from source, everything is transparent, happening in a sandbox you control. Auditing? It used to be a nightmare trying to trace where things came from. Now, your graph.json is your complete audit trail. And reproducibility? That's a huge one. It's guaranteed. Anyone with that graph file can build the exact same software, bit for bit, every single time.
What does this all add up to? 100%. 100% visibility into your software. No more guesswork, no more blind faith. You get a complete, provable understanding of every piece of code and every single tool that touched your software.
So really, this is the big transformation, right? The black box becomes a transparent glass box. We're moving away from this world where we just accept these opaque packages and cross our fingers. Instead, we're building with components where we can see everything inside, check that it's all good, and take complete control over our own software supply chain. So, I'll leave you with this. When you treat your dependencies as a graph, you can build a software supply chain that is fully auditable and verifiably secure. Your own is, anyway. But what about everyone else's? What about the software you depend on? Is their supply chain auditable? That's the question we all really need to start asking.